So today we're going to talk about the Internet of the Things network architecture and security challenges. Actually, Internet of the Things is very commonly usable devices at the moment, which interconnecting the whole world at the moment, and IPv6 is coming for that. So architecture and security is one of the architecture is very important, and security is really a challenge at the moment to such a millions of devices to connect together and giving them the security in the cloud. So let's say IoT defined devices, object connected in communication by internet. Actually, as I said, the millions of devices connecting at the same time with the different from the different part in one houses, from houses, from hospitals, different places. All the devices are interconnected with the smart objects. So applications are such as smart homes, healthcare, agriculture, smart cities, even with the mobile applications, a lot of devices are interconnected with the different applications. That's what giving us the benefit to improve the efficiency, enhance the convenience, and real-time insight, and it's giving us cost savings. That's what we have seen in our COVID, during COVID, that how the interconnected devices helping us to do the things. Major challenges coming when it comes to the security, security and scalability. This is the major challenge at the moment we are facing to in the world to give the security, send the data in efficiently without giving the data away with this in a secure way. So for the secure way, basically in terms of security, this is IoT architecture is very important to consider it for the security purpose. So there are basically two types of security layers of IoT architecture. One is there is 5-layer architecture and there is 4-layer architecture. So currently, basically at the moment in this portion, this paper, especially paper, uh, we are considering only 4-layer architecture. One is application layer architecture. Basically, all the applications and managements has been connected there. Analysis unit that's analyzing the data and making the decision unit. Yes, can you hear me? Internet network layer, interconnect internet gateways, network gateways, and network technologies, which is data acquisition system. Connected together and connecting all those things at the same time. The major advantage of this layer designing of this is to it will have a modular and flexible design, scalable, incorporated, and secure. It enable the new IoT application developments. There are different types of IoT network exist. One is wireless personal area network, which is considering the short range, utilizing Bluetooth and Zigbee. That's used for the home automation and personal health monitoring wearable devices. Technology commonly used for, again, this is for home automation and industrial automation and smart cities. For a wide area network using 4G and 5Gs, but using this kind of networks used for the transportation and logistics and environmental monitoring. Low power wearable devices considering the LoRaWAN and Sigfox, commonly used for agriculture and buildings and cities. Satellite network used for the basically used for the maritime and aviation sector is expensive, and it's expensive to decide, and so it's using a little bit low. Power line communication using for the data transmission and power line. This used basically for the smart homes and smart grids applications. Network selection is very, very important when you are based on our application, what application we are using it, and what are the networks what we are selecting. And that's how the evaluation will come. And the communication protocols also considering the what application we are using, what layer you are using. This is very, very important. MQTT using for the lightweight published uh, subscriber messages, which is suitable for the low bandwidth and high latency network and resource constant devices. Constant application protocol, which is a lightweight protocol, and for memory power and limited devices. It is based on the client server architecture and resourceful. RESTful interfaces. HTTP using for the feasible communication between the web and server, used for web interface and accessing the console IoT devices. ZigBee basically for the low power wireless protocols and home automation devices, and using the 2.4 gigahertz frequency band. LoRa enables a long range connectivity over several kilometers, utilizes the low power using sub gigahertz frequencies. For especially LoRa one is using, I was using in my last one of the project, which is used for the bushfire control and bushfire understanding, how bushfire is determined based on the soil and considering the soil water level and from the weather, combining this with the machine learning algorithm. Bluetooth low and BLE, which is Bluetooth low energy, which it is designed for the low power devices like wearable and smart homes. Near field communication for the short range is of course we are using every day with the smart control access control device, access control cards. Protocol selections is very important to decide the how IoT will be working. Major challenges, as I said, then challenges IoT networks, which is basically the scalability, developing the network architecture and capable of handling with a huge number of devices. Interoperability, ensuring the seamless communication between the devices with the protocol. Yes, security is one of the major part, as I was telling it, which is private physical security, preventing the tampering, theft, and vandalism. Authentication and access control is another problem. Implementing strong authentication mechanism in the devices you are using, such as NFC. NFC, when you are using NFC, the memory is so low, so that the communication protocols, everything is so low, it's very difficult to use a high level of strong authentication mechanism. So how to do that, which is a very big challenges. Another one is the encryption mechanism, protecting, ensuring the data encryption. Again, with the low power devices, it's very difficult to do the encryption. Software vulnerabilities coming, which is regularly updating and regular update software and mitigating the risk. DOS is denial of service attack is another major attack, which is implementing traffic and preventing the disruption. So sometimes it's jamming the networks and not allow to proper sending and receiving the data. So data privacy is said because if we use the, for example, health issues, in the health sector, the IoT devices, so safeguarding the data is another major part to do that, so that our personal data does not go away to the others. Supply chain security is another, ensuring the security through the different supply chain. Multi-layer approach is good, incorporating the physical and technical organizational measures and ensure the security privacy. Design consideration is very important, how to, which device to use, what is the, when you are designing the IoT, which is the IoT device to be used and what is the application layer. It's a rapid growth, it is a rapid growth technology, and it's basically its success depends on the security. Currently, actually, our team, myself, is working on the security purpose and how we're going to work on the security. In the, I have there's another data privacy conference is coming. I'm written another paper which is going to be present in October. I didn't take time today because anybody have any questions, you can ask me, because I have communications and software issues and communication problem in Wi-Fi and other, and I'm running out. Anybody have any issues, you can write me the email as well, and I can answer in my email. And any issues, anybody have any questions, please let me know how to for the implementation application and the security of the IoT devices. Thank you very much.